So this is where you're going to want to have your graphing calculators handy, because we're going to be using those to help us. All right? So a linear equation in 3 variables has 3 distinct variables, each of which is either first degree or has a coefficient of 0. Okay? Just as the 2 numbers that satisfy a linear equation in 2 variables are called an ordered pair, the 3 numbers that satisfy a linear equation in 3 variables are called an ordered triple and are written x, y, and z. Okay? Graphically speaking, you can kind of think, like an ordered pair makes sense, right? We think of the 2-dimensional plane, and we can go left, right, up, and down. Well, when we think about an ordered triple, now we're talking about like 3 dimensions. You can talk about left, right, up, down, and like back and forth. Okay, kind of thing. If you want to think in that sort of thing. Okay. When we talk about the set of all ordered pairs, ordered triples, so all ordered pairs, okay, they can create that satisfy a linear equation, they form a line. But all the ordered triples that satisfy a linear equation in 3 variables, they form a plane. Okay, so we're essentially talking about trying to intersect planes here, which is a little bit trickier to do because now we're getting again in space as opposed to just on a plane, on a flat surface. Okay, so if you look here, here's some kind of diagrams of some planes. Okay, so in these diagrams, okay, for example, in this diagram right here of the 3 planes, how many points lie on all 3 of these planes at the same time? Do these planes even intersect? No, in fact they don't. Okay, so there are none. Okay, here the planes intersect with this 3rd plane here, but they intersect at different places. Okay, here it's these 2 planes are intersecting, and they create a little line. And here, this plane and this plane intersect, and they create a little line right there. But nowhere do all 3 intersect. And then here again, they intersect, but only intersect a pair at a time. Here it's like 1 pair right here. Here's another pair of intersection right there. There's another pair of intersection. Okay. But there are situations where we can get 3 planes intersecting all at the same time. And here's an example right here. Right, you have this flat plane, and then intersecting these 2 kind of like perpendicular planes. And this single point right here, okay, kind of in the corner there, that is a solution. Okay, so that's kind of like graphically or geometrically speaking what it looks like when we're trying to solve one of these things. Okay, so here is how we're going to solve a system. Now, if you look here, okay, one way to do this is using substitution. We're not going to do that. I'm going to show it to you real quick here how you can do it using substitution, but it is intense. Okay? So let me just run you through it here real quick. So first of all, here's our system of equations. Okay? Kind of zoom in some there. You'll see we have 3 of them, 3 equations, and they each have 3 variables, x, y, z, x, y, z, x, y, z. Okay? The directions here say to choose an equation and variable to start with, and try to pick one. The easiest equations to solve are those that have a coefficient of 1 and solve it for y. So for example, they pick the first equation here, they see that the y has a coefficient of 1, and so they solve this top equation for y, which involves adding 2x over, subtracting 3z over, so they have y equals 2x minus 3z plus 20. Okay, so that's not that bad. But now what you would have to do is take this, the 2x minus 3z plus 20, and plug it in for y, both here and here. So you're going to plug it in here and here. Okay? And you'll distribute. So you can see they do that. They plug it in there, then they plug it in there. And they simplify it down to this. And so we have another system to solve. But this system only has 2 variables. So then we can do another substitution. We can add a 5z over here and get it solved for x, and then plug that x value in over here. Or they might use elimination. I'm not sure what they do. No, they substitute. Yeah. So they solve the system there, and they end up getting this. Okay? And they're finally able to solve and get x and z. They get the z value first. And once they have z, they can plug it back into their earlier equation here, and so let's get the x value of -4. And then once they have z and x, they can plug those back in and finally get the y value. Okay? It's a lot of work. A lot of work. Okay? A lot of substitutions going on. Okay? Or we can use our graphing calculators. And the graphing calculators, they help, but it's still not super easy. It requires some work. And we're going to use matrices, okay? So guys, have you guys ever used a matrix before on your graphing calculators?
Nope.
No? Yes, you have? Some of you have, yeah? Okay. So here's what you need to do. So let's get these graphing calculators out, because here's an easier way to do it without having to, do all that substitution and stuff like that. It's still going to take some time, but it'll be at least a little bit easier, because I think you'll see. All right, so first of all, to get to the matrices, if you look on your graphing calculator, you see there's a matrix word. Oh gosh, it's hard to see it. It's there, I promise. It's above, yeah, the x to the negative 1. You can see it right there in blue. Let me see if I move my book out of the way, let me see if that helps. That might help some. Yes, it does help some. Okay, you can see it right there. So you got to press the second button, and then x to the negative 1, and that'll take us to the matrix. Okay? So we're going to create two matrices here. You can see there's a lot. We're only going to focus on A and B. Okay? So to fill values into these matrices, we have to go over to Edit and hit Enter. We're going to edit them. Okay? Matrix A is going to be a 3 by 3 matrix. You've got to hit 3 and then Enter, 3 and then Enter. Okay, so we're going to make a 3 by 3 matrix, and you can see we now have 9 things to fill in. Okay. If you look at our original system, we have a 3 by 3 matrix of coefficients right here, right? Negative 2, 1, 3. Negative 3, 2, 1, 3, negative 2, 3. Right? You see that? And we're going to put these coefficients of our variables into the matrix. It's very important that you put them in order. So if they're not in order, right, you need to rewrite the equation so they are in order. So it needs to be x, y, z, x, y, z, x, y, z, just like that. Okay? So we're going to do that. So in my calculator here, let's see if I can get this to show up on the same time. Basically. Okay? We're going to plug in negative 2, then 1, then 3. So that's the coefficients, negative 2, 1, 3. Let me put them in the top row there. The next row, negative 3, 2, 1. And the next row, 3, negative 2, 3. Okay, so there are all of our coefficients. Okay. Now, there are 3 numbers in this system that we ignored. What are the 3 numbers that we ignored so far? What didn't we use yet? The other side of the equal side, the 20, the 21, the negative 9. That's going to go in our other matrix. So, first thing we need to do is do second mode and quit back to the home screen. Then we're going to go back to second x to the negative 1. Okay, go back to the matrix menu, and we're going to go over to Edit and down to letter B now. Okay. Matrix B is going to be a 3 by 1 matrix. Okay, and you see the way it's set up, we just need a column of numbers here. That's it. So guess what goes in there? 20, 21, negative 9. Okay, just like that. All right. So now we'll quit out one more time back to the home screen, and we're almost done. Now we're going to do some matrix mathematics. All we're going to do is go back to the matrix screen, and we're going to use our 2 matrices that we just filled with information. We're going to hit Enter for A. So we now have the matrix A described on our home screen there. You're going to hit this little x to the negative 1 button. So it's A to the negative 1. You see that? A to the negative 1. I just pressed that x to the negative 1 button. Now you're going to press second, go back to the matrix menu, and then do B. So we're going to do A. That means inverse, and then B. Okay, you ready for this? And we hit Enter. Negative 4, 3, 3. And you ready for this? Therefore, the solution to the system of 3 linear equations is the ordered triple, negative 4, 3, 3. Okay? So the calculator does solve the system for us as long as we can type it all in correctly. Okay? That's what the most important thing is. You got to type it in accurately, obviously. Okay? But there's the solution. Okay? Exactly right. X, then Y, then Z. As long as you put it in that order from the start. Okay? It's that simple. Shall we try another one? Let's try another one. Okay? Okay. Here's another one for us. Page 207. This right here. Okay. Negative 2x plus y plus 3 equals 20. Negative 3x plus 2y plus c equals 21. 3x minus 2y plus 3 is equal to negative 9. So first of all, when you come across a problem like this, you want to make sure, are my x's all in the right spot? Are my y's and all my z's? Are they in the right spot here? It goes x, y, z, that's good. X, y, z, that's good. X, y, z, that's good. We got numbers over here. So it's all in the right order. We're good to go. Okay? So we're going to go back to matrix A. So second matrix, right? And we have to edit. Hit enter. And now we have to, it's still a 3 by 3, so you can then arrow down to the matrix piece. And now you're going to enter these new coefficients. So let's see. Oh, what the heck? Is this the same thing? It's the same stupid problem. All right, hang on a second. Well, let me fix this then. We'll do a different one here. All right, here's a different one. Sorry, let's go to page 208. They for whatever reason, they had us do the same problem. So let's do 208 here. That one. Okay, sorry. But again, it's still in the right order. X, Y, Z, X, Y, Z, X, Y, Z. We're good there. So I'm going to take our little matrix here, and now my first row, what numbers do I put in? 1, 2, and then 3, right? It's like the count. 1, 2, 3. Okay? And then the next one. 1, 3, 2. And then 1, 4, negative 1. Okay? That's all of our coefficients there. Alright, got those coefficients in? It's 1, 2, 3, 1, 3, 2, 1, 4, negative 1. It's very important you type these numbers in accurately. If you mistype a number, it's going to throw everything off. Okay? Ready for the next matrix? We have to do matrix B now, right? So we're going to go second matrix and then edit matrix B. It's 3 by 1 still. And now we'll put, instead of 20, 21, and negative 9, what are we going to put? What numbers go in there now? 9, 5, negative 5. 9, 5, negative 5. There they are. Okay. Now we're going to second quit back to the home screen. Okay. If you have one of the newer calculators, like Miranda, Estefani, Connor, you guys can actually arrow up to the thing that you typed before, hit enter, and it'll just copy paste. And you just gotta hit enter again. And it'll give you the new solution. Okay? The new solution is 2, negative 1, 3. If you don't have one of the newer calculators, that's fine. Again, what you do is you're just gonna press second matrix, you're gonna do A, and then don't forget the inverse button. Like that, A, inverse, and then matrix, and then B. And hit enter, equals the same thing, 2, negative 1, 3. Okay, so there's the new solution there. Okay? Questions on any of that? All right, let's do one more. I want to show you kind of an interesting application of this. Well, I think it's interesting. You guys probably be like, not impressed, but that's okay. I guess I'm a math teacher, and that's why I find this interesting. Go back to page 205 real quick. Okay, go back to page 205 real quick. Okay, example B here says, there is a unique vertical parabola, and when they mean vertical parabola, that means like the the U-shaped kind of parabola, or like the bell-shaped, kind of upside down, frowny face parabola. There is a unique vertical parabola that passes through any 3 non-collinear points in the coordinate plane, provided. What's that? Upside down. Oh yeah, shoot. I guess sorry. Upside down smiley face. So a frown. Yeah, a frowny face. Okay. So there's a unique vertical parabola passing through any 3 non-collinear points in the coordinate plane, provided that no 2 of the points have the same x-coordinate. Find the vertical parabola that passes through the points 2, 1, negative 1, 4, negative 2, 3. So just like in the equations of lines, right? Any 2 points will create a line. Okay. You can create a line just given 2 points. You can create a parabola given any 3 points, as long as none of them share an x-coordinate. So, how can we go about coming up with this parabola? Well, here's what we're going to do. We're going to use the general form of a vertical parabola is the quadratic equation, y equals ax squared plus bx plus c. Notice, y equals ax squared plus bx plus c. You can see where we're going to put our y and our x coordinates, right? It's just wherever we have a y coordinate, we put that y value in there, and where we have an x coordinate, we put the x value in there. So here, for example, the 2, 1, that point, we'll put 2 in for the x, 2 in for the x here, and 1 in for the y. So we end up with 1 equals 4a plus 2b plus c, so 3 variables, right? Plug in negative 1, 4. 4 goes in for the y coordinate, so we have a 4 there. Negative 1 squared is positive 1, so it's positive a. B times negative 1 is negative b. And then c, well, there's, again, no x there, so it's just c. And then for the last point, 3 goes in for the y. Negative 2 goes in for the x, and squared is 4, so you get 4a. And then minus 2b, right, because it's a negative 2b, and then plus c. There's our new system, okay? So now to figure out the equation of this parabola, we're going to use our matrices to solve this system. Okay? You need the 3 points, and you plug them in for the x and the y. You get these 3 equations. So now let's go to our matrix and let's do this. So second matrix, got to edit it. It's a 3 by 3 still. Okay? And so now what numbers go on our top row here? What? Good. It's in a different order here. The numbers are on the other side here. So yeah, it's 4, 2, and then 1. Okay, and then 1, negative 1 and 1, right? Positive 1a, minus 1b, plus 1b, bless you. And then for the last row, 4, negative 2, and 1. We'll do second matrix again, edit, because we got to change matrix B, and then it's going to be 1, 4, and 3. 1, 4, and 3. Okay, from these numbers right here. Go back to your home screen. Matrix A, inverse, matrix B, hit enter, and there it is, negative 0.5, negative 0.5, 4. So the equation, this quadratic equation then would be, let's see, do they have it listed? Yeah. So then if we turn to the next page here, we can fill in the blanks. So based on the numbers that we got, okay, based on those numbers that we got, it's going to be, our A is negative 1/2. Our B is also negative 1/2, or I guess it's, or they already have a minus there, so I'll just leave it as a 1/2, and then plus 4. So it's negative 1/2 x squared minus 1/2 x plus 4. All right, that's it. So I want you guys to try here 2 and 3. Okay, try numbers 2 and 3, please. All right, on page 206. This will be just to check to make sure we're okay, and I'll give you guys, your assignment. Okay? So use those calculators to answer 2 and 3, please. Use your calculators, please, to answer 2 and 3. And I'll do it here real quick, too. stuff we did before, it was a parabola that we were writing, but this is just a system, that's all. So it's just going to be a Dutch order triple, that's all. I see what you're doing there, though, yeah. All right, so let's see how we did here, all right? We're finishing up, good. Okay, so, number 2, okay, all you're doing here was just finding the solution, the ordered triple, okay? This is just a system, so there's our ordered triple. There's matrix A and B in case you wanted to see those, okay? Number 3, okay, again, there's our matrix A, there's our matrix B, and there's our ordered triple, 2, negative 6, and 3. Okay? Questions on anything there? Pretty nice, right? Okay, pretty nice stuff. This calculator takes care of a lot for us in this kind of stuff. All right. I have one other little question for you just to see here because, well, some interesting things can happen. What if we come across a problem? Well, like I'm going to assign you guys maybe something like number 1 here. Okay? What problem do we run into here with number 1? If we're going to go try and make our matrix, in which equation? The bottom one. You guys see that? Oh, sorry, page 216. Page 216, number 1. Exactly right. Okay? So if you look here, it'd be a 4, then a 1, then a negative 2. It would be then 2, negative 3, 3. And then the first one would actually be 1, because that's the x is 1, then negative 2. But then the z, there's no z there. So to represent no z, 0. You're just going to put a 0 in. Okay, so it'll be 4, 1, negative 2, 2, negative 3, 3, 1, negative 2, 0, and then your other matrix will be negative 6, 9, and 0. Okay, so it makes it a little bit, that's all you got to do, just be on your toes there. Okay, here number 2, the second equation is missing an x, so it'll be 1, 5, 3, 0, 4, negative 1, 6, negative 2, 4, and then your other column there, 4, 3, 0. Okay, so just be on your toes about that. So here's what I'd like you to do. I would like you guys to just do numbers like, oh heck, I don't know. How about just like, how about 1 and 2 on page 216. And I'd also like you to try, ooh, I'll write it up here on the board that way. So page 216 numbers 1, 2. I'd like you to try number 10, because that was like that one example that we saw. And then I'm gonna have you do one problem back from that previous section that we talked about. The solving the systems of linear and quadratic equations. I'm going to have you do number 12 on page 198. So 198, number 12. Okay, so 4 problems. You have 25 minutes to get those 4 problems done, so there's a very good chance you get them all done before the weekend's here, and then you can have no homework for the weekend. And I'll be happy to come around and help you guys too if you get stuck on something. Okay, so let's try and knock out those 4 problems, please. So let's get those problems done here. Again, use your calculators for 1 and 2, and for number 10 as well. That'll actually be helpful. You just may need to write some stuff out first. Bless you. Well, that's a good question. Let me see here. Are you doing number 1? So I did not. So I would suggest you go back and check your matrix there. Yeah. And then if you look at your matrix. Okay, I was gonna say if you don't see what you did, I'll be happy to come back and take a look at it then. Okay, Jason. So number 2, there will be fractions or decimals. And the nice thing is, when you get that fraction answer, you can actually hit math, enter, enter, and your calculator will convert those decimals into fractions in the matrix for you too. If you want to make it, fractions instead of decimals instead of fractions instead of decimals. So, but number 2 does have decimal answers. Just as a heads up. At least I'm pretty sure it does. Let me check. I guess I should check my work too. Yes, it does. Yes, sir.
How exactly are we supposed to do this? I don't really understand it when you do it.
Okay, so if we go back, I'm going to draw it on the board here so you can see. If you want, you can here. Or if you want to turn around this way, there, and you can look at me while I'm on the board here. Okay, so we've got, so those points need to work in our quadratic equation. Remember the standard form for a quadratic equation is this.
Okay, I got that now.
Right? And so now, equals y. So put your x's in, and then y goes here. You'll have 3 equations because you have 3 points. So first x coordinate and first y coordinate, and then second x coordinate, second y coordinate, and then third x coordinate, and then third y coordinate.
How do you know what A, B, and C are?
That's just it. That's what you'll be solving for in this case. You see what I'm saying? It's not the x and the y that we know now. We're trying to come up with these 3 numbers. So when you get your answer...
I think I get that.
Yeah. Okay. What's the first point, Craig?
3, 7.
So 3 7, so that means you're going to have 9a plus 3b plus c equals 7. That's going to be your first equation. So we'll go 9, 3, 1 in the matrix, and then you have to come up with the other 2. Does that make sense? Okay. Want some help? Yep, I'll be right there. 1 second. Okay, so this is that one problem I was kind of talking about, an interesting application of this system. So you're writing the equation of a quadratic is what you want to come up with, right? You have 3 points that you're told. What are those 3 points?
3, 7, 30, negative 11, 0, 1.
So, because these 3 points are supposed to all be on the same parabola, they all should work in this equation here. Exactly. So the very first one will be a times 3 squared plus b times that 3 plus c equals the y coordinate 7. So the thing you put in the matrix then is going to be 9, 3, 1, and then the other, you know, the other matrix will be start with a 7. And so then for this one, it'll be and so then the next row of the matrix will be 30 squared, which is 900, 30, 1, and then the other matrix will be negative 11. So on and so forth. You see what I'm saying there? Once you solve the matrix, you'll have the a, the b, and c values. That will be the equation of the quadratic. Make sense? Okay. So it's kind of like reverse what we're doing. We were given like the a's, b's, and c's, and then told to find the x, y's, and z's. Now we kind of have the x, y's. We're using those to find the a's, b's, and c's. So it's a little bit backwards, but it works.
He added me on Snapchat.
Oh, he did. There was fire yesterday.
Oh, yeah.
Did you see? You
No.
can see the smoke from.
I heard the siren.
You can see the smoke from the intersection of Lawyers Mill and Old National.
Really?
Yeah.
I heard the siren. Where was it? What was it about?
The West side.
And,
And then
What's up, Emma? You ready?
Yeah.
Okay.
Just the one question.
Yes.